In this video, we're going to be comparing passive transport of molecules across biological membranes and active transport. And as we go through each one of these types of transports, we're going to answer the following questions. Which way are those molecules moving? Are they moving across the membrane towards a higher concentration or away from the higher concentration of that molecule? And that means then, are concentration gradients being built? Are they being made? Or are these concentration gradients being depleted? Does this movement of molecules require energy? In the movement of these molecules, is energy being released or is energy being required? And finally, are there any special transmembrane proteins embedded within the membranes that are necessary for this type of transport? So let's take a look first at passive transport. And what we see here is in each case, you see molecules moving down their concentration gradient. And what that means is they are molecules that are moving from a place of high concentration to a place of low concentration, place of high concentration to a place of low concentration. And what that means is we have a concentration gradient already set up that we are using, that we are depleting. So as these molecules move down their concentration gradient, we will at some point no longer have a concentration gradient, as the concentration of that molecule is going to be the same on both sides of that membrane. Now this type of transport, this passive transport, this transport of molecules moving down their concentration gradient, does not require a source of energy. In fact, energy is released. We are using the stored energy of this concentration gradient that allows these molecules to move down their concentration gradient. And when we do that, energy is released, and this energy can be used to do work. We're going to see examples of that later on in the course when we talk about mitochondria, but for now it's important to realize that when molecules move down their concentration gradient, energy is released that can be used to do work. Now, there are two basic types of passive transport. There is simple diffusion, and that's what you're seeing here. These molecules are just moving straight through the membrane. Now those molecules have to be small, they have to be non-charged to be able to do that. And we have facilitated diffusion, and what that means is, since we're moving larger molecules and charged molecules, we need a path for them to get through the membrane, and channel proteins and carrier proteins, these are transmembrane proteins, they provide the paths that these charged or polar molecules can use to move through that membrane. Let's take a look at active transport. Everything is sort of opposite here with active transport. What we're doing is we are moving molecules up their concentration gradient. So here is a proton, and we're moving it from low concentration to high concentration. That's up its concentration gradient. And so what you see, because we're doing that, because we're pushing them against their concentration gradient, we are creating concentration gradients. We are creating a side of the membrane here, in this case out here, where there is a higher concentration of the molecule that we're looking at. And sometimes these gradients are chemical, so they're just chemicals in nature, and sometimes they can be electrical. So for example, protons, these hydrogen ions, are charged. And so not only do we have a chemical gradient, we have an electrical gradient that we're building as well. A positive charge on the outside relative to the inside. And we call these type of gradients electrochemical gradients. And now that we've established and built a concentration gradient, to do it, first of all, we required a source of energy. We needed a source of energy to pump those protons against their concentration gradient, and pump them and stack them out here. Now those sources of energy can be ATP, it's kind of like the cellular battery, but the sources of energy can also be, as we'll see in the next slide, a previously established concentration gradient. Okay, we'll take a look at that in a minute. So what we do here is, number one, it required a source of energy to do this, but number two, that energy now is stored. Remember, energy cannot be destroyed. It can only be transferred into another, or turned into another type. Well, that energy of the ATP that was used to make this concentration gradient is now stored in this concentration gradient. This active transport always requires proteins. We have the proton pump that you see here. There are sodium-potassium pumps that you will read about in your textbook, and there are co-transporters, which we'll look at in the next slide. So, as we said, an active transporter, something that pumps molecules against their concentration gradient, always requires a source of energy to do this. Sometimes that source of energy is ATP, but sometimes that source of energy is a previously established concentration gradient. So let's take a look at a sucrose proton co-transporter. And what it does is it pumps sucrose against its concentration gradient. So it sets up a sucrose concentration gradient right here. Now remember, because it's pumping sucrose against its concentration gradient, it needs a source of energy to do so. What is it using? It's using a previously established concentration gradient of protons. So here we have lots of protons out here. Here we have very few in there. So as those protons move down their concentration gradient, that energy that's released, remember what we said, things moving down their concentration gradient release energy. Well, that energy that's being released is being used to pump sucrose against its concentration gradient. So the question is, okay, great. Where did this proton gradient come from? Well, it was made by a proton pump. Where did that proton pump get the energy to pump those protons and make that proton concentration gradient? Well, in this case, ATP. Okay, so it's all about transferring energy from one source to another, and then linking these sources of energy and coupling them with processes that require energy. And that's what you're going to see in biology quite a bit. One energy source being converted into another, being used to do work. So in the end, here we have the characteristics of passive transport compared to that of active transport. Passive, molecules are moving down their concentration. Active, molecules are moving up their concentration. In passive transport, concentration gradients are being depleted. In active transport, they are being created. In passive transport, this use of a concentration gradient doesn't require any energy. In fact, energy is released. For active transport, it requires a source of energy. We need energy to push those molecules against their concentration gradient. But once we do that, now we have a source of stored energy that we can use for later within that concentration gradient. In passive transport, there are two types. Simple diffusion, that is when molecules are just moving straight through the membrane. They don't need transmembrane proteins. But those molecules have to be small, and they have to be non-charged and non-polar. And then there's facilitated diffusion. This is the type of passive transport that allows charged or polar molecules through, and that requires the help of transmembrane proteins. Active transport always requires transmembrane proteins, things like proton pumps, sodium-potassium pumps, and co-transporters.